So portfolio is basically a group of assets, right? Group of assets that an investor can actually put up so that he can reduce the risk. The main aim or the main objective of having a portfolio is normally to reduce the risk. So I want us to look at a question from where we stopped yesterday. I want us to look at a question in 2019. November, question number 3. Question number 3. Question number 3. This one, question number 3, B. So we can read the question. It says, Duncan Kipchumba has an investment capital of 1 million. He wishes to invest the fund in 2 securities, that is X and Y, in the following proportions: 200,000 for X and 800,000 for Y. The return on these 2 securities depend on the state of the economy as shown below. So we have the state of economy, we have probability, then securities X and Y. We have the state, which is boom, normal, and recession, with their respective probabilities and returns for each asset. Required, the expected return on the portfolio. Number 2, the correlation coefficient between security X and security Y. So normally expected return of a portfolio is normally given. Normally the expected return is normally given of a portfolio is normally given by adding the expected return for each assets. That is, you get the expected return of asset 1 and then asset 2 separately. Then you multiply them with their weight and add. So what we basically want in this particular question so expected return of a portfolio is normally given like this. Is normally the expected return, that is weight of X times expected return of X plus weight of Y times expected return of Y. So this means that we need to calculate the expected return for each item, then we'll be able to calculate the weight. Weight is basically the proportion, right? It's normally the proportion that you're using. When you're investing, where do you give more weight? Like now in this case, they have 1 million and they're taking 200,000 somewhere, another 800,000 on another investment. So that is how we can be able to get the weight. You can get the proportions or the ratio. So weight can be gotten. Sometimes it is a percentage, or in this case, they have given us 800 for Y or 1,000. That is for Y, which is giving you 0.8. That is weight for X. Sorry. Then we have weight for so this is for X. Then we have weight for Y, which is given as 200 all over 1,000. There we have 0.2, which is the weight for Y. So that means that here you have 80%. Here 20% is invested on Y. That is basically the way. Look at what the question has given us. They have 1 million. 200 is going to be on X and Y. So it is the opposite. 200 is on X. 200 is on X. And then 800 on Y. Sorry. So that we have like that, right? 80%. This is 20%, which is the same as 2. So basically, from this question, we can easily get our weight. Those are the weights. And for us to reach at the expected return of our portfolio, we need expected return of our portfolio is weight times the expected return of the first item. Then we calculate the weight times expected return of the second asset. We add them. So this means that now that we have our weight, we have our weight, which we require. So we have W, X is equal to 0.2, and then we have W, Y is equal to 0.8. You leave them there and now look for another thing. We now need to calculate expected return for each asset separately. We have them here. So the expected return of assets, which you can say expected return, is given us for X is given us the probabilities times each return. So that is this times this plus this times this plus this times this. That is for X. So we shall start with. Thank you for joining. Just remain silent. Thank you for joining. So we have 0.4 times 1.8 plus the other one is 0.5 times 1.4 plus 0.1 times 1.2. So that is how you get expected return. In some questions, they will ask you question number 1, get expected return for each security. So this security X or asset X, that is how you get, that is the probability times the return, and then probability times the return, then you get the summation. From here, it is probability times the return plus probability times the return, probability times the return. So this will give us, I know you are in the office or you don't have a calculator, but we can easily do something. So this one will give us, if you could assist with the calculation, we can go very fast. Thank you so much. So this one will be 7.2. This one is going to be 7.0. This one is going to be 1.2, right? So that we have the total, this and this, that is 14.2 plus this one, 15.4. So we have here 15.4. That is the return for the first security. Then we come to the second one. 0.4. That is for Y. Let me share with you the screen. 0.4 times 24, then 0.5 times 22, times 0, then 0.10, 0.1.21. So that is 0.4 times 24. You can calculate for me using your phone. We have 0.5 times 20, 22, plus 0.5 times 21. So what are we getting there? When you calculate that, you should be able to get this one. This one should give you 9.6. This is 11, right? Then this one should give you 10.5, right? Can assist me calculate? Kindly keep silent so that you don't interfere with your neighbors. So we are basically getting security for each asset first. Then we can now use it. Weight we have gotten. So this one will give you 9.6. This one will give you 11. Then the other one should be 0.1. Sorry, this one is 0.1. So this times this should give you 2.1. So you add the total. 11 plus 9.6 plus 2.1. You get here 22.7. Now, those are expected return. Those are expected return for the assets, right? Now, we want to get the expected return of the portfolio. That is what the question requires, expected return of the portfolio. So you get it by having, you call it expected return of the portfolio. You simply have the weight of X times expected return of X plus weight of Y times the expected return of Y. So we have here weight of X, which is given as 0.2 times this one, 115.4 plus weight, which we have 0.8 times 22.7. Now, if you calculate that, you'll be able to have what we are looking for. So this one will give you the 3.08 plus this one is going to give you 18.16. When you add the two, you get the answer there. So it is giving you 21.24. Now that is the expected return of the portfolio, right? Now the second question is asking for correlation coefficient between X and Y. Correlation coefficient between X and Y. So keep these ones. I don't know why we can keep them, but I can write it here because now we have our ERX is equal to 15.4. Then we have ERY is equal to 22.7. Then we have our ERP is equal to 21.1. 21.24, right? 21.24. So we can wrap these ones and proceed. How do we get our correlation coefficient? Correlation coefficient, we have to get it by working on covariance. So it is the covariance of xy all over risk of x times the risk of y. That is what we got yesterday. So this means that we have to calculate covariance of xy. So covariance of xy is equal to, we say that co means the differences, how they vary, right? So we have to calculate covariance. With covariance, there is no square root. You only get how they vary. So that is the return of x minus expected return of x times return of y minus expected return of y times the probability. That's what we agreed on yesterday. Kindly confirm if that is what we actually learned yesterday. Those who are there. Is that the formula for covariance? So we get summation of all that, summation of all that will be the answer, right? So we start with the first one. We know the expected returns, and then we have security for each item. So we have the first one, security is 18. So you have 18 minus x, expected return for x is 15, right? 0.4. So we have 18 minus 15.4 times, this other one is 24, right? 24 for y, that is 24 minus, mean for y is 32.7, times the probability for all of them is 0.4 on that line. So we have 0.4. You get the answer. Then you come to the second line. Second line, covariance, how this one varies and how this one varies. So you take 14 minus its probability, which is 15, its mean or expected return, which is 15.4. Then we also have here 22 minus 22.7 times 0.5. Then we have another one, 12 now. So we work with 12 and 24. 12 and 21. So you'll have the 12. Yeah. Yes, 12 and 21. So you have 12 minus 15.4 into 21 minus 22.7 bracket times 0.1, which is, you get the summation of this. That is covariance. That is the covariance. We needed covariance because it is part of the formula that will help us to get the correlation coefficient. So, we'll be able to calculate that.
Correlation coefficient.
Somebody is making noise. I said that you mute, but you have refused. Sorry for that. So we have 18 minus 15.4. Here we have 2.6. So we have 2.6, this one, 2.6. Then we have this one, 24 minus 22.7. It is 1.3. So it is 1.3 times 2.6. Times 0.4. 1.3 times 2.6 times 0.4. 2.6. So that one is giving you 1.352. Is it 3.3 when you multiply it? 2.6 times 1.3 times this. Just confirm. Somebody to confirm. Yeah, thank you, Deborah. Let's confirm. This times this, mean napata hii. Hebu confirm kama unapata a different thing. Tumia tu simu. 2.6, 1.3, and then 0.4. Multiply it. In the meantime, I'll try the second one. So when you multiply this, this will be negative. Negative 1.4. This one will be negative 0.07 times this one. So what do we get? So that is the correct one. Thank you. The next one is 0.49. Then we have this one. Here we have negative 3.4. This one we have negative 1.7 times 1. So what do we get there? 0.578. So we simply add them, and that will be our covariance. I brought this example because there is something important in it that you need to listen to. We didn't cover it, though I'll still share the video, but it's good that you have that concept. It will be the last example that you're doing for this class. Then we move to another area. So this one is giving total of 1.24048, which is the same as 1.24. So that will be the covariance. Or you can say, yeah, 1.4. That will be the covariance. So let's now get our risk so that we can complete the formula. So our covariance, we have it here as covariance of xy. We have it, I'm just keeping it, 1.24. Well, let's get the risk. How do we get the risk? So we look at the risk for each asset. So we have risk for x is given as the square root of the summation of the deviation of return of x minus expected return y of x. Sorry. And then that one squared times the probability. That is where we are. So what's in the question? We need to get summation of the differences now. So we can start with summation for x. So we have return for x, that is 18 minus 15 point, right? Square times the probability, which is 0.4. What do you get? Then we come to the next one. 14, right? So we have 14 minus 15.4 squared times 0.5. Then we come to the third one, which is 12. So we have 12 minus 15.4 times 0.1. What do you get? That is the one for x. We can also get the one for risk for y, which will be, you can be getting me these ones as we look for risk for y. Is given as 24 minus 22.7 squared times the probability, which is 0.4, right? And then we have the other one, 22, right? Then we have 21. So that is where we are. We need now to get the total here and also the total here. All these are squared. So we have 24 minus 27 minus 22.7. We are getting 1.3 squared times 0.4. We are getting 0.676 on that side. Then we have the other one, the difference between that, and then you square, we are getting 0.246, 0.245. What have you given? 0.9. Here you get it 0.27, and then I'm seeing 0.9. So this one, actually it is 5. Then we also have this one, 1.7 squared times 0.1. This one is giving 0.289. 0.289. So when you add total of this, it's giving you what? 1.21. Then you now get the square root. Remember, we're getting the square root of the summation. The summation is an ones. You now get the square root of the answer that you're getting. So square root, so dx is equal to square root of 1.21, which should be square root of 1.21 should be 1.1. This other side, are you calculating for me these ones? Total is 4.8. So here you get total of 4.8. 4.84. Thank you. So the first one is 2.70. 2.704. Thank you. This one is 0.98. This one is 0.15. No, it is 1.156. So the total becomes that. Then now the square root you are giving me dx is dy. This dx is equal to, which is giving you 2.2. Nice. So we have our dx and dy. So we can simply say that therefore correlation is the coefficient, which was 1.24 all over 2.2 times 1.1. What is the answer? Just like that. So 1.14 times 2.2. Now divide by 2.2 times 1.1. So the answer becomes the answer is 0.62. That is what I'm getting. So that means that is that the correct one? Should be covariance is 1 point or it is 2 point? Is there anybody who had calculated the covariance? We see the figure. Is it 1.24 or it is 2.24? What did I write? It was 2.24, thank you. So when you have 2.24 here, so what do you get here? Mine is becoming what do you get? I'm getting 1, which is positive. So if it is 1, which is positive, what does it mean? That the correlation is actually strong, right? It's exactly 1. That means that this is not a perfect combination, right? They are moving towards the same direction. The maximum correlation is 1, that is positive. So it is a perfect positive correlation. That means that if you are losing, you lose fully. If you are gaining, you gain fully. So it is not you're not reducing risk at all. By investing in this kind of project, you're not reducing any risk at all. You're not reducing any risk at all. So let's look at the next question. So this means when you realize that you're not reducing any risk, that means that the total risk of the portfolio is the combination of the two risks, because you're not reducing risk. So when you're getting risk of the portfolio, you don't use the formula that you used the other day. You are basically getting the risk for each item